Our responsibility as operators doesn't end when the water leaves the plant. Our primary job is to ensure that water remains safe all the way to the tap. Out in the distribution system, there is a hidden vulnerability. Even slightly corrosive water, continuously rushing through aging municipal infrastructure, can slowly leach lead and copper from old pipe solder into the drinking supply. To neutralize this continuous leaching, we rely on a specific chemical compound, zinc orthophosphate, or ZOP. Managing ZOP shifts our focus from treating the water to protecting the pipes that carry it. Our objective is to adjust the water's properties so it shields the city's vulnerable delivery system. Zinc orthophosphate, chemically represented as ZN3PO42, comes in a few forms. The automotive industry uses a powdered version to rust-proof cars, but municipal plants use a liquid formulation because it integrates rapidly into high-volume water flows. As this liquid mixes into the supply, it reacts with the water's chemistry. It coats the inner walls of the city's pipes with a microscopic film. That film creates a physical barrier, blocking the corrosive water from reaching the old lead solder. Without this precise microscopic reaction occurring inside the pipes, the drinking supply remains completely exposed to the heavy metals in the infrastructure carrying it. Inside the facility, our bulk liquid ZOP is stored in these large-capacity vertical tanks. Because of the chemical volume, you'll see secondary safety features built in, specifically the overflow lines routing directly down to the containment bays. From storage, the chemical is pumped into the distribution flow. We manage and monitor this entire dosing process from the automated control panels. This graph charts our active dosing strategy. When we first introduce ZOP to a system, we set an initial target between 1.0 and 2.0 milligrams per liter. This elevated dose is temporary. We hold it here strictly to push the chemical deep into the network, forcing the protective residual film to reach the furthest dead ends of the city's grid. Once we establish a steady residual throughout the network, we dial the concentration down to our maintenance phase, stabilizing at a target between 0.5 and 1.0 milligrams per liter. The primary operational failure point during this process is overdosing the chemical supply. Pushing too much ZOP into the system gives the water a distinct metallic taste. If consumers drink it at highly elevated concentrations, it can cause upset stomachs and nausea. Maintaining strict numerical targets on your control panel is the only way we balance adequate pipe protection against immediate public health hazards. While ZOP is safe at trace levels in the water supply, OSHA officially classifies the bulk material as a hazardous chemical, requiring strict handling protocols. You can verify the specific hazards by checking the standardized NFPA diamond affixed to the center of the tanks. Before you handle the valves or perform maintenance, you must equip the correct personal protective equipment. That means wearing chemically resistant polyvinyl chloride, or PVC, gloves, along with dust-proof clothing. The storage environment has its own rules. These tanks must remain in a well-ventilated area, and you must keep them strictly isolated from any strong oxidizing agents. Operator safety relies entirely on treating the routine maintenance of this equipment with the same rigorous care you apply to the chemical itself. If accidental exposure happens and ZOP makes contact with your skin, abandon your task immediately and move directly to the nearest emergency wash station. Scrub the affected skin with plain soap and copious amounts of water, then immediately remove any contaminated clothing. If the chemical gets into your eyes, flush them continuously while manually holding your eyelids open. If you inhale the fumes, evacuate the area immediately and get to fresh air. Speed of response and strict adherence to these medical protocols are what prevent a minor exposure from escalating into a major medical incident. Our function with zinc orthophosphate is clear. We build an invisible, microscopic wall to stop heavy metal leaching. Accomplishing that requires two daily responsibilities. You monitor the strict milligram per liter dosing targets on the screens, and you wear the correct PVC protective gear before any physical intervention. Before you begin your next shift, locate the plant's official safety data sheet for ZOP and map out your route to the nearest wash station. The technical precision you maintain on the plant floor keeps lead and copper out of the community's water supply.